Welcome, students. Today's learning journey is going to be about energy flows in an ecosystem. We're going to look at trophic levels, look at food chains, food webs, and something called an ecological pyramid. The big word for today that we're going to focus on is this concept of flow. Energy flows. That means it moves from one area in a direction to another area. When we look at feeding relationships and energy flow, we're going to look at food chains, we're going to look at food webs, we're going to look at trophic levels, and these ecological pyramids. As I said before, our big area of focus today is going to be on the fact that energy flows through an ecosystem in a one-way stream. We go from something called a primary producer to various consumers, and we're going to draw arrows that are going to show this direction. Food chains. So the first part for today is talking about food chains. And food chains, we have arrows that point to show energy flow. And this occurs in one direction. So whenever we start with the food chain, we're always going to start with a producer. Another name for a producer is an autotroph. We talked about that earlier. So an autotroph, auto meaning self, troph having to do with energy level. So we start with our autotroph. Our autotroph will then give energy, and I talked before about energy flow. So our autotroph is going to give energy to this grasshopper. So the energy is going to flow from the producer to the grasshopper. Our grasshopper is going to be our primary consumer, primary meaning one, and the energy from that grasshopper is going to flow to the snake. We have energy flow. It starts at the grasshopper and moves to the snake. Our snake is our secondary consumer. So I'm almost trying to sound like a snake with a s sound here. Secondary consumer, second consumer. First one's a grasshopper, second one's the snake. Our energy then flows from our secondary consumer or our snake to our tertiary consumer. Tertiary meaning three, and our energy flows from the snake to the hawk. We then off to the side have usually write down our decomposers and our detritivores in this area. So a lot of times we don't necessarily include them in our food chain, but they are part of the whole process of energy flow. Next thing we're going to talk about is a food web. And a food web is a more complicated food chain. Actually, it's a bunch of food chains linked together. We know that organisms don't always just eat one thing. They often eat more than one thing. And this food web is going to show that. So if we take and look at the lion's going to either get energy from the gazelle or it can get energy from the zebra. So these are two food sources for the lion, two ways that the lion can get energy. All that energy originally starts at the grass level, and we talked about that earlier. So grasses are going to be our primary producers, and the grass is going to give energy to the gazelle. So we have energy flowing in one direction. That gazelle is going to be our primary consumer, meaning it's the first consumer that we're going to have. Consumers consume or eat energy. We also call those heterotrophs. This gazelle that's our primary consumer is going to give energy to the lion. Energy flow, right? Primary consumer. Our lion is now our secondary consumer, so our lion becomes a secondary consumer. And we can also look at the food web from the other angle, where we look at our grass giving energy to the zebra. Remember, we're drawing energy arrows from our producer to our primary consumer. So our primary consumer now is the zebra. The zebra then gives its energy to the lion. Also, when the lion dies, it gives energy to the vulture. And our vulture is actually our detritivore in this example. So the detritivore would be the vulture. Now let's look at a more complicated food web, what it actually would look like in nature. So we're going to start with our primary producers, which are our grass. Grasses produce their own energy, primary producers. Our grass is then going to be eaten by the zebra. So the zebra is going to take the energy from the grass and ingest it. That energy is then going to be transferred to, in this case, the cheetah. So the cheetah is going to get the energy. Energy arrows are showing where energy is moving. Can also look at this other example, and you notice in this example where the zebra is being eaten by the hyena, the energy actually flows from the zebra to the hyena. That is why that arrow is pointing from the zebra to the hyena. Over here we have the tree is giving energy to the elephant, hence the energy diagram showing that way. So one more time, we have, when we look at these, we have our primary producers, which are our green plants. We have our zebras, which are our primary consumers, our herbivores, being eaten by our cheetahs, which are secondary consumers or our carnivores. We also have decomposers and detritivores on the bottom here, and our primary consumers, like I said, are herbivores. So if we look at this example here, producers, first level, giving energy to our zebras, which are our primary consumers. That energy is going to the cheetah, which is our secondary consumer. Now we're going to look at something called a trophic level. Trophic means energy. Talked about that before when we discussed the whole autotrophic, heterotrophic. And we're going to look at energy and what we call these levels. So our first level is our first trophic level is the producers, because they actually produce the energy that's required for all other living things. Second trophic level, we have herbivores and omnivores. Our third trophic level, we have omnivores and carnivores. And our fourth trophic level, which is the maximum trophic level, because there's little energy left, and we're going to talk about why there's little energy left in just a minute. When we draw out trophic levels, we actually put them in reverse in a way. We're going to make something called an ecological pyramid. It's going to look like a triangle. And our first trophic level is going to be on the bottom. So this is our first trophic level. And our second trophic level is going to be on top of that. So we have our second. Then we have our third. And then we have our fourth. Omnivores and carnivores are going to be found in this level. Our herbivores and omnivores will be in this level, and our producers will be on the bottom. Maximum trophic level is the fourth. We're going to look at why it looks like a pyramid in our next slide. Now we're going to look at ecological pyramids. This right here on the side is another way of looking at that triangle that I drew earlier. At the bottom we have our oak tree, that's our primary producer. So we have our producer. Our next one that we have is going to be our primary consumer. The next one's going to be our secondary consumer, and this one on the top is going to be our tertiary or third level consumer. What we have going on here is showing a representation of energy and biomass. So over here, on this side right here, we have our energy pyramid. The energy found in this oak tree is going to be a lot larger, hence the bigger square, right? It's a lot larger. We have more energy in that oak tree than this caterpillar is going to get. So this caterpillar is going to get some energy, but he's not going to get as much, and that's why the size of the triangle decreases as we go up. So we have this bird here, our tertiary. He's going to get some energy, but he's not going to get as much energy as the caterpillar had. And our sparrowhawk is going to get just a little bit of energy. We're going to discuss what happens to this energy that's disappearing in our pyramid in just a minute. The next one we have is our biomass pyramid. That's this right here. And that just simply states that the mass, or the weight, if you want to describe it as weight, we're just going to ignore gravity for right now. The mass, when we look at something on the bottom here, is going to be a lot greater than the mass when we are looking at the top. So here's our mass on our bottom. We have a bigger area. You'll notice it's a lot bigger. More mass, more objects. Next level we have less mass. And we continue to go up our pyramid, we have less and less mass, less weight of things in our pyramid. This diagram right here is going to show us energy. And what ends up happening is you need to have more energy at the base of our pyramid. We just talked about ecological pyramids. And on the bottom here we have our producers. Remember, our primary producers, they get energy from the sun. That energy is then transferred to our primary consumers. Our primary consumers have a smaller amount of energy. And that's because we lose that energy in the form of heat. So in the process of this grass giving energy to these grasshoppers, a bunch of energy is lost as heat. So we have heat loss. Next level that we move to is from the primary consumers to our secondary consumers. And once again, these grasshoppers are walking and hopping around. They're not just moving, they're hopping around. And we can look at it this way. If you and I eat food and we never lose any of the food energy we eat, we'd end up weighing like a bazillion pounds. Because all those calories you take in, if you keep them in your body, you're just going to get bigger and bigger and bigger. But you and I run up and down the stairs at the school, and we're very active, and we lose a lot of energy. And we lose a lot of it as heat, and we know that because when we run around, we end up getting really warm. So a lot of this energy is lost as heat. And this happens at every level. So when we lose all this heat energy. When we go from grasshoppers to these shrews, the shrews are going to lose a whole bunch of heat energy because they're running around too. And then when we go from the shrews to the owl, that owl is also going to lose and not get all the energy because energy is lost as heat. And in actuality, only 10% of the energy is conserved between trophic levels. And you can see that because we have 1,000 kilocalories for the producers. If we move the decimal point 1 to the left, instead of 1,000, we end up having 100 kilocalories. Then we have 10 kilocalories, then we have 1 kilocalorie. Though that difference, that 90% difference, is lost as heat. So let's look at this over here. If we have on the bottom of our pyramid, we have producers, and they have 5,000 kilocalories of energy. We're going to take that decimal point and we're going to move it over 1. So our 5,000 becomes 500. Our 500, when we move the decimal point over, becomes 50. 50 then becomes 5. So what we have here are our, oops, I'm trying to move this and I'm not getting the arrow to move like I want to, so we're going to try making another one here. Sorry for this. There we go. So 5,000 level, primary producers. A lot of energy is lost as heat, right? Most of it is lost as heat. And then from there we go to our, oops, wrong thing. I'm going to have to undo that. Hang on a second. Then we're going to go to this level. This is our primary consumers, our herbivores. They're going to lose a bunch of energy due to heat. Good thing I don't write like this normally. Then we're going to go, I'm having that problem again. I'm just going to move the whole slide, guys. Then we're going to go to our, first we had our primary consumers, right? So we have our primary producers, primary consumers, secondary consumers. They're only going to get 50. Then we're going to go to our tertiary consumers. They're going to only get 5. This is why we don't have any ecosystems usually that are more than 4 trophic levels. That's because we lose all that energy. When we get to the top, this guy up here has to eat so much stuff to get any energy. He's going to lose all of his energy trying to catch food. This is also evident, this whole energy loss system, is if you look at a big tree, this big ginormous tree, and this tree, as big as it is, can support lots and lots of little insects. So we have one tree with a lot of mass supporting a lot of insects. And those insects are not as big as the tree because they don't get all the nutrients that this tree has. We have now reached the end of my Explain Everything presentation. Hopefully you found it helpful. If you don't, please come to class with any questions or just write them down. Can watch this again. I would love your input to know if this was helpful for you or not. Thanks.